Hello everyone, welcome to the Tech Talk 22. We have first a talk from Dan Acristinii about Kubernetes in hospitals, how Roche manages edge clusters worldwide. And afterwards, Daniel Lorch will talk about building generative AI-powered apps with MongoDB Atlas. And at the end, we have Nick talking about service mesh. And afterwards, we have some snacks and beer. So we stream live. If you want to follow us on YouTube, please do so with our nice QR code. I hope it still works because it was some time ago since we last streamed. And our next event, Tech Talk number 23, will be on the 6th of March 25. So looking forward to seeing you again there. Oh, if you want to follow me, that would be the. Oh, that's it from my side. So handing over to Dan.
Cool. Okay, let's go. Let's try to present this. I did not even check where the presentation is. That's a fun start. So, wait, I'll do this so I make sure. Drive, at least I have the Wi-Fi. Let's go. Clearly it is not available. Public, Edge, here we go. Found it. Put it back. Slideshow. Hope the screen will work. Okay, looks good. Fantastic. So this is kind of interesting because I have never presented this platform outside of Roche. Usually our engineers do this talk where they actually walk you through the technical part. But again, these slides are not approved, so great. But again, considering the community, considering I know you, I take this with a grain of salt. This is really a bit of sharing of how internals work for us, and I might explain some stuff. This is the official name that I have to say, as this is the official title of the platform, Navify platform. You can see it also over here. Navify is the Roche brand for digital products, actually. You will never see Navify platform mentioned anywhere because it's an internal thing. Now, I work for Roche. That is a lab. So it has two parts. One is pharma. They do medicine. They do pills. Interesting. We're not talking about that today. We're talking about diagnostics. So that's the thing that is usually based in Rotkreuz. And this is a massive lab. One of the massive labs that we have, I think with the longest conveyor belt in Europe, is in the University Hospital of Zurich. If you have a chance, I hope you don't have to go there. But if you can visit, it is quite interesting to see. And basically, you see all of these instruments that analyze your blood. For example, COVID tests. So there's conveyor belts all around where they take the sample and they move it around, or they do a lot of great things. On the instruments, there's usually either Windows or Linux. It depends on the generation of the instrument. It's another product in our product line. Interesting, not the focus of today. Usually in such labs, there's a couple of smaller computers. Those computers are not attached to the instruments, but they're sitting in the lab processing data, checking if maintenance is done on those instruments, hosting applications sometimes. And that's what we're talking about today. So even though this can happen mostly in a lab, also there are some deployments where we do inside hospitals, some inside pharmacies. I'm not sure how many actually those are, and research institutes as well. So even though there is a cloud component to this, the most important part is that do not process the data in the cloud. Process data locally, output some of the important stuff into the cloud. But sit over there. So in many cases, this is how it looks like. So there's an instrument that has whatever operating system it has, and then there's the edge cluster over here. Why is this important? This way, you do not have to run the validation of the system and of the software inside the instrument, right? If you push an update, you don't have to do the entire approval process of like a medical device or whatever it is. You're not touching that. If this breaks, that doesn't break. That's very important. It's not a dependency. This means we can move and work into a cloud-native environment, right? We can push updates. We can install Kubernetes, which if you update Kubernetes every 10 years, you might have a problem. Fortunately, we don't have a challenge, right? In some cases, we are not good internet connectivity. In some cases, we are air-gapped. Of course, it has its own challenges. But most cases, because it's sitting in a lab where it's not necessarily a critical device, you can install things in a cloud-native way. There is a firewall sometimes over there, Cloudflare connectivity towards Roche, and yeah, the fancy stuff. Very simple things why this is important, right? So as I mentioned, don't move the data. It's sometimes really not an option, so keep that over there. Compliance, again, you move the data, you have a problem. Bandwidth, you would be surprised what bandwidth we find sometimes. Sometimes it's 10 megabits, and that's a good case. And that's it. Latency also, if you need to process something fast, I mean, it's really kind of clear. This is, I keep joking that this is my boss. He looks a bit like that, so I just keep throwing the slide in it. And it's really, the part is, you always think of Roche as pharma, fine. Maybe you know that they have diagnostics, fine, interesting. But when I say digital products, so actually selling software, you're like, wait, what, do they do that? Yes, we do. And this is kind of the point. I basically took our intro slide for like onboarding of an interview or something like this, and I just redid it a bit, so sorry about that. Now, let's talk about technical architecture for a second. Now, we have this global concept. Global is basically a massive Kubernetes cluster running in AWS, but it is basically orchestrating everything else. What does it mean? It runs a couple of services that basically support us provisioning these guys. These guys are important. So, in Kubernetes, control plane, worker nodes, fine. It's not the same. We use the same nomenclature, but it doesn't mean that. These are also Kubernetes clusters. Now, these Kubernetes clusters can be spun up on different cloud providers in different regions because they have their own container registry, they have their own OIDC provider, they have their own API server where basically we use to provision these guys. These are the business value, right? These are the edges where you actually run your workloads. These are the things to which you connect these guys. Kind of a simple architecture. You might think Rancher. Think of this as Rancher on steroids, because we used to have Rancher and we had to kill it because Rancher does not work well with many disconnected clusters. There's a lot of talks about this from our team. You can talk about that. Now, this is really technical now, so I can actually continue and using some of this time. This is global. So, fun fact, I don't usually do this presentation. Usually the tech lead does, but I didn't want to steal his slides, but I took some of his screenshots. Okay, let's go. So this is external services. Doesn't necessarily matter a lot. It's basically SSO, Splunk, Vault, GitLab, whatever. This, don't look at it, doesn't matter. Authentication and an image registry. This is very important because we want to be able, if you push once, we can distribute your image everywhere. And some additional services, that doesn't necessarily matter. China, actually, fun fact, quite important. We have to do a replica of our container registry because you do have problems with connectivity, permission, many things. So our global extends a bit. Ideally, this would be on a control plane level, but because of China, we have to host these servers separately to guarantee that you can still access this. Now, this is the fun part. So yes, the setup on ID code is kind of similar. What do we run on these regional control planes? So if you would imagine Rancher, when you connect to it, this local cluster, it's kind of that. So you have a bit of monitoring that the edges can connect to and they can basically show up. It's important to see if something is broken or not. Pass-through authentication. This is kind of funky. So Keycloak can work as a server and a client. If this one is set up with the official Roche SSO, you cannot easily spin it up and spin it down. You need to have kind of a stable environment because that one requires tickets to configure. You've done your tickets, you've configured ones globally, but now you can use basically Terraform to provision them up and down. So this helps us to be able to spin up on different ones without having to create tickets. So this is all Terraformed, quite easy to do. What else do we have? I mean, of course, we have the image registry, which helps us to provide faster image downloads. And this thing might be interesting to see this talk. Basically, each cluster from of the edges can connect to the control planes, and we give them let's say we call it the cloud tunnel. So just think of it when you download the kubeconfig, the kubeconfig needs to connect somewhere. Rancher offers this, we had to rebuild it. It's using Chisel, so kind of easy. And, no, wait a second. Edge to cloud tunnel, yeah, let's assume that for now. When I go to the next slides, we'll go. And Vault, nothing new. Some supporting services again, doesn't matter. And finally, the edge. What is an edge? So this is most of the stuff that is running on our edge cluster, right? So important is actually Cilium. Operating system is Talos. If you know what that is, great. If you don't know what that is, think of Bottle Rocket, Flatcar Linux. How is it called from Fedora? Fedora, CoreOS, Lite, something. What? Whatever. You know what it means. Basically, you use YAML to describe the operating system. This one is an operating system based purely on APIs. There is no shell. It's built for Kubernetes. Really funky stuff. We're, I think, one of the few companies really using it. Really nice for us. Policy enforcement, nothing crazy about it. We use Cilium for a lot of funky stuff. So you would think that you can use Cilium for just CNI, right? What do? You don't have traffic from your cluster to something else. You install in CNI, now you can push traffic. We do a bit more. So if your application needs to connect to an API somewhere else, these are labs. The labs don't necessarily have firewall rules that allow star, right? So you need to be a bit careful of how the data flows. If we ask every single application to basically whitelist all of their IPs, they have to go to the customer IT. Because I work for infrastructure, I am at the level where it really is convenient for me to enable applications to do better. To basically, you tell me you want to connect to S3. I will take care of that for you. I will make sure the path goes the right way. It's not a firewall bypass because we still basically inspect the traffic, but it goes via our control planes to the right endpoints rather than going directly to the right endpoints. And also it's a very nice way to basically, if a customer has a proxy, we hide it from you. We add the right packet headers. You don't need to know. So Cilium, really intense tool we use. Actually, some of our contributions and requests to Enterprise Cilium have ended up in open source Cilium. There's a talk about this. I'll mention it in a second. You're welcome. So at this point, I am open for questions, but I just want to share with you. These are the actual people behind this, and I'm not the technical person. I used to be a technical person. This is not my position anymore. So I'm making sure that these guys are having a happy life, and I'm dealing with the budget and the work orders. So this is Alex, it's our tech lead, and this is one of the presentations where we show basically GitOps at scale. That means that for managing so many clusters, we need to find a way to basically change Git on a large scale because we want to use Flux, but we also want to template. And there's cookie cutter and all of that thing. We built the tool, we open sourced it, it's available over here. And this is probably the same presentation I'm doing today, just done better. And this is the part where we explain to you how we bypass firewalls. Really good talk. They will explain to you why it's not actually a bypass of firewalls. And this is the Talos thing. If you haven't heard of Talos, really recommend have a look because for Kubernetes, it's a really funky operating system. And yes, you know me, nothing new. And this I will kill because this is an internal slide for, how's it called? For onboarding. So I'll put it here and I will say, you're welcome, you can ask me for questions. Yeah.
How do you manage connectivity from mainland China to the rest of the world? Would you know that? Because that's the big Chinese firewall.
Yes, you are extremely restricted at what you're allowed to push, right? So we encourage usually product teams in China to push to the local registry over there. So that's why we have a second global registry, which is exactly where we recommend. But again, because we're global IT, we also push towards there. To push is not a problem from global to China. To push from China to global is a problem.
Are you pulling out data?
Yes. Exporting data from China is a problem. Yeah.
How do you connect the lab machine to the cluster?
So it depends on the machine because every single instrument usually has a very proprietary driver. Some of them are open source, most of them are proprietary running on Windows, which requires Other things. Fortunately, it's not my problem to solve, as I'm making sure that the drivers or whatever application is running on the cluster. And then Roche itself is dealing with this connectivity in between Roche instruments, other types of instruments, and within there. So I'm providing the application hosting platform, and they're running the application, which actually talk to the instruments. I ensure that you have a path via the TCP stack to connect to it. I don't ensure what you connect to it. I mean, it's also at one point you need to set responsibilities. There is an entire business for this, and that's a different part of the organization, which actually builds the connectors to the instruments and everything. I work for informatics, which is infrastructure layer. We need to make sure whoever is building apps, we have the pipes. What you put on the pipe, not my problem. Okay, cool, folks. So next presenter, and I'm going to hand it off.
Cool. Let me mirror the screen, right? And I hope I can keep up the energy level of you then. Displays, arrange, use as main display. How do you remove the mirroring? I'll try like this. I might need to hope that works, right? Cool. Okay, so my name is Daniel. I work for MongoDB. I'm a solution architect for MongoDB, and I think most people, they kind of know MongoDB or have heard of it, but very few people know that's actually a company behind it. And we have in fact, more than 5,000 employees worldwide, and let me see, 65 offices, yeah, and one in Zurich, in fact, like 200 meters from here. So the Zurich MongoDB headquarters is very close to the Deploy.io headquarters. And a lot of customers also. There's also a commercial offering behind it, an enterprise offering, a cloud-based offering. And I will talk a bit more about especially Atlas, our cloud-based offering. And as you know, or just as a reminder, MongoDB is a document-based database. That means we store information as structured documents. And the difference to a relational database, right, where you have even on a simple example of an address book, where you normalize the data, we put all of the information together. So it's much more intuitive. As you can see on the right-hand side, right, all of the information is together. It's also faster because just to fetch one object, right, everything is together. We can just have one read operation, one write operation, and it's much more flexible because you can very easily make changes to it. We don't have a very fixed schema. You can just make changes as you go to the documents. Now, documents are universal. They don't have to be, just JSON objects in that sense. They can be tabular. We support GeoJSON support. You can do geo lookups on data. We have full text search support. So you just add a index on search. You can do, autocomplete. You can do fuzzy search on data. We have native support for time series. So very efficient storage of time series data, very efficient lookups also on time series data. And really combine everything that is, the strengths of relational, so ACID compliance on transactions, very complex ability to write complex queries, not just CRUD, but also what we call aggregations, multi-stage queries that can filter group data, lookup data, reference data, and combine that with everything that is NoSQL, right? The flexibility of what you know as NoSQL. Now, MongoDB is more than just the database. We have a cloud-based offering, as I mentioned, called Atlas, what we call the developer data platform. It's more than just the database itself. It's the integration into, let's say, object store on the cloud, so you can move data into object store, can still query that. You can replicate across cloud. We're multi-cloud. We don't have our own data centers, so we run on the hyperscalers like AWS, Azure, and GCP. Not yet on deploy.io, right, Tom? And also have a lot of additional options. We have also integrations into partner solutions for offline sync, and plenty of possibilities to make you productive. And depending on where you last remember using MongoDB, and that's a slide I like to show, we will not go through everything, right? We introduced Atlas in 2019, so a couple of years ago. Have quite some experience operating and running and offering MongoDB in the cloud. We introduced time series support, as I mentioned, tooling around migrating from relational to document. It's called Relational Migrator. And what I would like to focus on today, since it's a tech talk, a bit on vector search, on the Gen AI part that we recently added. And we'll dive into that now. Any questions so far? Otherwise, I will just dive into the next part, right? I'm sure you've all worked with, played with ChatGPT by now. I think it's nothing new anymore. And when I ask it, what are the top 3 songs this year, it knows the answer because it has been trained on information that is in the public internet, or is able to make the lookups to the internet, and is able to give me that answer. But when I slightly rephrase that question and say, okay, what are my favorite songs? It will not know the answer. And I have to give that information somehow to the model, right? So behind this are what we call foundational models or large language models when it's related to text. They are trained on a vast amount of data that is typically collected from the internet. So the information that they have access to is also from the internet. It's not from your personal space or whatever you, unless there's no password on your website. But yeah, but the question then is, right, how do I add the personal stuff to the LLM? And yeah, so the question is, what kind of data should we give to these models? And what is then the relevant data that I can feed to that model so I can answer questions like, what are my top 3 songs? What is something that is relevant to me, right? My private information. And that leads us to a question of what is a vector. Because, well, let me first get into that, right? All know vectors. Vectors are just sequences of numbers, can be any kind of dimension. Vectors can also capture some sort of meaning. And for example, a vector can represent a color. So these are 3 numbers in the RGB coordinate system. That's a color. So a sequence of 3 numbers can mean a certain color, a certain a hue, a certain intensity of color. It can also mean other things, right? So black is 0, 0, 0, and so on. Now, a vector embedding then is a vector that captures some sort of meaning. So when I say I listen to Beyoncé, that string, right, it has a certain meaning. The vector representation, as you all know, is just a sequence of numbers that is representing that particular meaning. Obviously, we don't really know. I'm just joking. We don't really know what these numbers mean. Usually, I can take, when I take some sort of unstructured information, some data, can be text, can be maybe an image, can be anything, audio, for example. Depending on the encoder that I use, the foundation model, that encoder can take that unstructured information and output a vector that represents that meaning. And that makes it really easy. That's basically reducing the dimensions of the unstructured data that I have into something that is much more manageable. It's a vector of certain dimensions that capture that, right? When I try to plot this on a graph, you can see like a king and a queen are close by, right, on the coordinate system. Woman and man, they are on the opposite corner of that coordinate system. And the same then goes further. Any kind of artists or omelette and pizza is probably a food item, right? Mongo and Kafka, they're technology terms. Beyonce and Kylie, they are artists, musical artists. So this continues. If you put that information of the vector on some sort of graph, you see that the similar clusters will give you the same meanings. Huh? Now, knowing that, then, well, the question is, right, if these vectors then are really big, not just 2 dimensions, how do you deal with that if the vectors are bigger in length? And now, when we work with vector data from LLMs, this is where MongoDB can help, right? It can store vectors efficiently and find vectors efficiently for GenAI applications, and basically interacts with a framework that you have to work with that vector data and work with the foundation model to do the embeddings and also the generation of the answer. Now I can show you a demo, and some people have seen it before, and they have told me, like in a previous Tech Talk, someone tried it and it didn't work, or attempted to do it and it didn't work. So let's see, that's a challenge. And let me go here. I think that's like this, right? So let's see, I'll just reload very quickly. Okay, so is the prompt legible? It's a bit small, huh? Okay. Okay, so what I've done, I've basically taken the docs9ch website. You all know it, right? I've ingested all of the information from that website into MongoDB Atlas, embedded it as vectors, and I'll show you the data so you can have an understanding of how that looks like. And then I put it into a small chatbot, and then I can ask it questions like, what is deployo? And now it's the demo effect, right? Let's see if that works. Okay, it's a fully managed platform where you just bring your source code for your web application and take care of building and deploying it continuously. Is that correct? Yes. Okay. And it also gives you the links, so it works, right? It's better than the other guy. You gave me that challenge. But obviously this one is not very interesting, because if you go to docs9ch, you have full text search here, right? So deployo, I'll probably find the same information through full text search because I can just go by the keyword. What's much more interesting if I ask it some more intelligent question, right? So I'm not sure, Tom, you mentioned something. What is the best hosting option for my web application? So the demo effect. What is the best hosting option for my web application?
Oracle Cloud.
Ah. So it will actually go to the best hosting options for your web application depends on several factors. VPS, managed hosting. what deployer offers. Okay.
But if you go to the second resource, because it shows related yes. Huh. It's only read from that, and it came up from that.
Okay, but okay. Can you give me a code example in C# for deployo? We tested C# is not supported, right? Oh, I made a typo. I'm sorry for any confusion, but deployo primarily supports languages like Ruby, PHP, Node.js. But then there's a Docker file beta support, right? So is that correct? Yeah, okay, yes. So that's actually...
Support for C# deployo.
Huh? Sorry?
Write support in C# for deployo.
So basically you wanted to build the C#.
Write it, code generated. That's a good one. Okay, so that's basically the output. Now the question, how does it actually get to that output, and how does the whole stack play together? Now I need to move that window here. So first of all, that's the config file of the. I'm going to show you a framework. It's just a sample framework that it's open source. You can download it, and it uses can integrate to different LLMs. Has different kind of sources, and one is the sitemap source. So I just indicated the docs9ch sitemap XML, and you can also give it PDFs and so on. And then you can indicate the LLMs. These are all cloud-based LLMs. Also Atlas, in this case, is cloud-based. And then the last question that I asked was, can you give me code example in C#, right? And let's try to dissect this a little bit. I hope. I'm struggling a bit to see it from the corner. Content. I mean, it's log output, so sorry, it's not really nicely formatted. Okay. And here's the last separator, right? I think, if I'm not mistaken. Okay, so from top to down, you can see there is a, that's the information that's sent to the LLM to generate the answer. Huh? So it starts with a prompt, and it says, you are a human-like chatbot, and receive some content. You will provide the answer to the question that the user asks. It's a system message. I think it's here, right? Role system. It's basically programming the LLM to do what it's supposed to do. And then it provides, with these wiggly lines, it provides the context. And as you can see, these are, well, it's not very nicely formatted, but you see these are chunks that come from the docs9ch website that contain the knowledge, the information to further program. That's the personal part that you inject right into the prompt. And that's what comes also from the database lookup, from the vector lookup. And essentially using all of this, and the rest is just debug information, I think. Can you give me code example? Oh, I really missed that. In C#. And using this information, the LLM is able then to produce the answer that you have seen, right? The prompt and then the context. This architectural pattern of injecting context into an LLM prompt is called Retrieval Augmented Generation, RAG. So it's the prompt, the context that you provide, and that's really where also then the vector search comes in, right? This prompt that I gave is put into a LLM. It's vectorized, and that vector is looked up in the database for similar stuff, as you have seen on the chart. And that content then injected into the prompt to generate the answer. That's essentially the flow. When you then look into the database, and is that legible? Zoom in. Can you see the documents on the right-hand side? These are the documents that are fetched from the ingestion. Basically, it goes through the sitemap, follows all of the URLs, and recursively follows the URLs, gets slices up the content into so-called chunks of size that you can configure, and then runs it through an embedding model. Basically, the embedding model is then providing the meaning of that data of the same chunk, and helps then also in the lookup, right? So when we're looking up by the vector. So the input prompt, vectorized, find similar vectors, return the chunks, insert the chunks into the prompt, and then generate the answer. So that's essentially the sequence. Questions, or is that good? Cool? Yeah? Good. Any more questions that we can answer the LLM? Write how? Write the C# so for deploy and deploy it, please. Not sure.
But it's not only looking at the docs, right? Some other data inside.
So
what model does it have?
So on one hand, it's the model that has generic knowledge, right? Yeah. So if I ask it, I'm glad you're interested in deploy and C#. Does that? Is that correct? We could run it. So I think it gives you now the code for the Docker file. It's not natively supported, but it uses the Docker file support, right? And I haven't tried it. It uses NCTL. That's the command line, right?
But gets that path go? Yeah, that doesn't work. Yeah, that doesn't work. Get URL empty will error out. That's not too bad. Yeah.
We can go back to the fragments that it's found. Yes, so to get to your question, Dan, it takes the LLM's generic knowledge plus the context information and produces the output. So I can ask it, what are the OSI layers? What are the OSI layers? Let me see. So it's also trying to find it, and I think it's not on docs. And then, oh yeah, okay. Standardize the functions of a communication system, and it's interesting. It did found.
Oh, that's a.
Okay, so the resources are not 100%. That's probably DDoS here, right? DDoS protection and configuration layers. Okay, so let's just scroll like this. So it takes the URLs from the fragments that it thinks are similar. There is some threshold configuration that I can set. I set it to really be permissive. I can make it more less permissive, right? And then generate the answer out of that. Yeah.
So by setting it less permissive, you could basically force it to only answer from the docs.
I mean, like this, I probably get too many results. I need to increase the threshold, decrease the threshold, give it less content from docs. Yeah. Yeah, because obviously the answer that it generated was not from that pages, and it kind of gets confused in doing that. Yeah. 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 So yeah, that's an option, right? It's different to the full text search that goes by tokens and words. It goes more by meaning. And okay, maybe what is the diff between NKE, managed hosting, and deploy? So these are three products, right? NKE, 9 Kubernetes, managed hosting. Not the wrong name?
No.
So let's see, ideally it finds the websites with these three products, it tries to compare them. So in summary, NKE is for deploying and managing containerized applications on Kubernetes, managed hosting for traditional server hosting, and deployer for deploying and managing web apps with ease. Is correct? Okay, yeah. It's only as it's only a smart, huh?
We're just to fire the salespeople.
Fire the, okay, so it's only as smart as the context that you give it, right? And sometimes it doesn't get it 100% right. There's parameters that you can tune. But it's fun to experiment with that. And I had a lot of fun trying it out also for this talk. And to get to your question, Dan, what are the FMs used? I used, it's from AWS, like the Bedrock was, I think it was Titan for text embeddings, that's for the prompt. And then Mixtral for then the answer generation. And depending on the embedding model, you have different dimensions of the vectors. This one produces 1024. It's always 1024. So that also makes it easy on our end to generate the search indexes on the data. Like here, search index, right? I have a search index on the vector index field. Oh, it doesn't show the config, but in a certain dimension. So I can easily search for that. Okay, cool. When you want to try this out yourself, so I mentioned I used a framework. It's a framework that's provided by MongoDB. It's open source. You can download it from GitHub. You can configure it. Has all of the ingestions and the glue, and allows you to integrate with different LLMs, different sources, and it gives you this whole glue around building a chatbot. Right? That's typically where a lot of people kind of start and find out. And it took me maybe 1 hour to get set up. And just getting to something that's working and kind of useful. Yeah. Cool, that was it. Thank you very much. And if you want to get in touch, I'm on LinkedIn and still here for beer afterwards. Yeah, thanks.
Can I ask a quick question?
Yeah?
In this example, you ingested the whole website, right? And in the document store, one individual item was just a chunk of
Yes.
the website, right?
Yes.
So you can use RAG on this just free text, right? But would you also use RAG on, in our case, we have Mongo with JSONs. The individual document is just a JSON with some, I don't know, business meaning, something in it, some data. So would you use RAG on structured documents as well?
Do you have an attribute?
Now you're just doing it on kind of free text. Right?
Yes, so here I ingested from an external source, chunked it up. If you already have data in MongoDB, you can say, okay, this is the field that I'm interested in, the text field.
Filter, like normal Mongo filter to make a query, where you say that this service would also somehow use LLM to create a good filter or a good Mongo query to look up in the structure.
You can, so if you have already a text field or something that you're interested in, you can run that through an LLM and generate a vector and just put that vector in the same document and make it searchable, right? So you don't have to search from externally, if you know what I mean.
Yeah.
So I can show you quick.
Somehow seems like defeating the purpose. Like if my documents are already structured, I can search it very fast.
So search it how? Search it.
Write a query.
Yeah, but exactly the most important thing is how to write.
No,
a
how?
query. So
An exact.
Natural language to a query with some very cheap model maybe, but just to retrieve the useful document and then look up.
Okay, so you can have an exact query on an object by some attribute. Maybe it's a numerical attribute. Or you can run a full text search, which runs by keyword, right? So these, I don't know, update, specified, these are keywords that are put into a search index. You can do that. Or you can go a different way and say, I want to have capture the meaning of what's in here. And then you need to run it through an embedding model and just add an embedding to your existing text. So there are different options depending on what you want to do. And you can also combine all of the approaches. You can do like a hybrid search and say, I want to search by text and meaning, because it's very different to say, give me everything that contains deploy.io as a keyword versus what is the best hosting option. Do you see what I mean in terms of the query? So do you know what kind of query you're looking for your data?
Yes. Just in one case, we were building like some, also with LangChain, like some agent that was supposed to search, like help customers to answer the question, I don't know, what kind of cars can I buy in this dealership? And then we have a bunch of documents from Ford, from Mazda, whatever, where they list thousands of models, and each of them, is pre-configured with an individual JSON, and they say, I want a white Toyota 24, Toyota Yaris. Can I buy it, and I think this embedding was, in our use case, a bit of an overkill. But this is maybe...
I see what you mean. It's maybe even a different use case.
Yeah.
So
that's what I meant, searching actual, where a document is.
Yes. There's actually a field here called generate query, and it takes a natural language query and converts that to a MongoDB query. And that's a different approach altogether, right? It's like, give me all of the cars that have a sunroof, and then it will return a query based on that. That's yet another approach to work with data. So that's programming the LLM to write queries. Actually, some customers are doing that as well. That's quite interesting. It's a bit different approach altogether than here, right? Yeah. Cool. I can show you some examples if you're interested. I have something afterwards, but yeah, okay, cool. Thanks a lot. Does it work here?
Okay. Yeah. Let's see. Okay. Yeah. Service mesh equals service mesh. That's my my topic. Down to the basics here. No LLMs and yeah, no complicated stuff. I hope. This is more of our journey. It's like a talk of our journey of connecting services. A problem actually, which yeah, was and is there for quite some time already. Yeah, something about me. My name is Sebastian. Everybody knows me as Nick. I'm a platform engineer at 9 since 2015. So soon there will be 10 years in January. And hobbies, yeah, I have a family. I love cycling outdoor, indoor, and wherever. And yeah, in electronics, I'm also a bit interested. The low-level stuff. Background, yeah.
describing the problem. We have various services running in Kubernetes and on classic virtual machines. That's the ground layer, right? We have NKE, where customers can run their stuff. We have also, for example, vClusters, and we have databases, on-demand databases, which run on virtual machines. We have, like the most recent product, I think, is the key value store thing, which actually runs on Kubernetes and not on a VM. And what we want is basically, we just want to connect those services. And yeah, customers basically want that. What the problem about that is, for example, on our NKE stack, you can't predict the outgoing IP. That's not possible because, for example, when there's maintenance, we're actually replacing all the machines. They got completely new IPs, and the pods move over, and then the outgoing IP is a different one. So that's not really predictable. So like the classical firewall stuff really doesn't work. And then there's also deployer, I forgot, where we also want to connect services from. I already said that IP restrictions are not really suitable anymore. And there's also, for example, in the database case, if you have a database, you might not want like the whole world being able to connect to the database. Maybe just your pod from your NKE cluster or your deploy application. So yeah, that's also a requirement. It would be cool if everything is basically like internal. And yeah, we can't provide this with the underlying network. That's just not possible. Like, for example, when you think of Google, you can create a VPC and you can use the same like IP range multiple times. We don't have that. We have a simple network, public IPs, connection from A to B, basically. That's a very simplified architecture of that, just so that you actually can have a look at it. We have a deployer cluster. We have the service cluster. Like if you have, for example, a product from us, Grafana, Tempo, or whatsoever, or KVS as well, the key value store instance. That's all running on the service cluster, on one Kubernetes cluster. Customers have their NKE clusters. We have databases running on VMs. And we also have like the classical managed servers, where normal hosting applications, web applications are running on. Maybe they also want to connect to one of our on-demand services. Yeah. And yeah, that was the issue, and still kind of is a bit, right? So we had the first solving attempt, and we're going back to June 2021. That's the time when we actually tackled that issue first. Back then, we had the whole database on demand coming up, put it on virtual machines. So customers ask, hey, I have an NKE cluster. Which IP should I put in? And we said, we don't know. They are changing all the time. So that project basically came up. And like, yeah, I will just do that. The projects we had a look at, Cilium external workloads. Back at that time, we only had a look at projects which actually were able to connect to VMs. So Cilium external workloads, we are already using Cilium as our service, like not service mesh, but our CNI solution. We had a look at Kilo, which is a WireGuard-based solution, Consul back then, Kuma, and we also like had ideas about custom solutions. And link to the results, and that's the thing which I actually prepared here, but due to the mirroring didn't work. Okay. So I don't know, it might be a bit small. I also don't want to show everything here. It's more like that you see how we actually do those things. So for example, Cilium external workloads, we tested it, and as you can see, advantages and disadvantages. Like the main disadvantage, I didn't get it to work. Back then, 2021, it's all back 2021, right? Yeah, it's a pretty harsh one, to be honest. Nowadays, I think it would be different, but back then, yeah. Yeah, we also have the issue that we, for example, want to connect multiple clusters to the same cluster, like the service cluster, for example, but we have multiple NKE clusters from customers. And for Cilium external workloads, back then you need to have a /30 subnet, which is basically used in that whole connection to the VM. And yeah, it wasn't really the one, or the solution which we were going for, I'd say. Then there's Kilo, a WireGuard-based solution. We had a look at, you basically have, I think, pods on the nodes, which act as the WireGuard proxy, and then stuff is basically connected in the cluster. And you can also have that on the VM. But one issue back then, right? was, for example, the VM always needs to connect to the so-called leading pod on the cluster, which is the leader for the whole WireGuard thing. And if that leader changed, you needed to reconfigure the VM. So that's a bit of an issue because in our case, everything needs to be totally automated. There's no one doing something like I can type, right? You know, that's not happening. Everything needs to be automated. And also, all these WireGuard-based solutions, back then at least, we always had a problem with managing networks. Like you have those private networks, which you can use for that case, but then if you have multiple things connecting to the same, they shouldn't clash. So they need to be unique, and you need to manage that. And yeah. So basically, Kilo wasn't the one which we've chosen. Based on that, ideas for custom solutions, also based on WireGuard. I don't know what that was. It wasn't chosen. And yeah, another idea: public IPs with dynamic firewall rules. never really looked at. Basically, the idea was here that we have something running on the database server on the VM, like a software, which checks, hey, what are the current IP addresses of the Kubernetes cluster, and I adapt the firewall rules dynamically. That was the idea. Yeah, provides no encryption, right? That's a bit of an issue. It just takes part of the authorization part. And I think nowadays, when I would like have a look at that again, the delay in some stuff might be a problem, right? So yeah. Console also we had a look at. Yeah, don't read the first disadvantage. It's pretty harsh. Yeah, let's say console wasn't also something we did consider. Also because of the like you need to run console server for per K8s cluster and per VM, which is already quite some overhead. We didn't want to do that, really. And then was actually the solution I bet on. Yeah, there's Kuma. That's actually readable, right? And back then, or even today, Kuma is like that universal service mesh thingy where you can have multiple clusters connected to each other, and also VM switches down there, but it's quite big. Actually, that's the database VM. And back then, we had a look at like how can you configure it, how would we actually do it, because Kuma supports like multiple meshes and multiple zones, so you need to find your desired architecture for that. And we came up with one mesh per organization and then one zone per K8s cluster and VM, which in the end means you need quite some types of load balancers, so you need quite some IPv4 addresses if you really want to get that going. So it's still cool. I actually built a POC with that, and I presented it to the team. And Kuma also works with so-called sidecars. Does everybody know what is a sidecar approach? You don't talk directly to the other application, but everything goes to your sidecar proxy. And Kuma is using the Envoy for that. And I presented that to the team. Also, the VM connection was working. And I was pretty proud of myself that I actually got that going. The thing was like the overall, the overall opinion of that was, how the fuck is that complex? It's so complex. I mean, really, do we really want to go that way? And there were other issues. For example, the connection between control planes, like remote control planes, and the global control plane. I don't know if you've seen that. There is a global control plane in Kuma where everything is like all the CRDs, where we define everything, and that's actually propagated to the remote control planes running on each cluster VM whatsoever. And the authentication between them back then and today still is only IP secure. So you need to know your IPs. If you want to have something better, you need to go enterprise. And yeah, connection to a service always has to use port 80. That was also interesting if you don't have like web service which you want to connect to. DNS is resolvable between meshes, but not connectable. Like if you have multiple customers, right, and then the DNS is resolvable. Yeah, it's interesting. And also another security related one was all CA certs and keys of all meshes are stored on every cluster. I mean, still it was or is stored or would be stored in our namespace. We have an own namespace on every NK cluster. But still, you just don't want the stuff to be stored there. So yeah, I was proud of myself, but in the end, yeah, people said it's too complex, security is not good. Please go on. Yeah, and from their own service mesh solution based on proxies with Envoy, kind of nice idea. But given just the sheer amount of development time which would need for such a solution, we quickly went over that. And we also had a look at Nutanix VPCs. Back then, Nutanix is our infrastructure provider for running VMs, and they provide a feature, VPC feature, the same as Google, for example. But yeah, back then it was a bit of technical and also license price. We don't know how much it costs issue. Yeah. So overall, going back to the whole thing here, the results, yeah, we would have to manage subnets with those WireGuards-based solutions. Complexity clearly is too high with sidecar-based things. And if we want to do anything like come up with something ourselves, it's way too much work. Security-related concerns for Kuma, right? The whole secure as certificates and keys are stored everywhere. So, yeah, project delay. We actually said, no, there's no solution yet in 2021, which we would, I don't know, we would like to use. So we don't know what to do. Let's wait for the problem to solve itself. Maybe some other projects will come up. Maybe others will be better, or maybe even the problem will go away. I don't know. Yeah, that was the solution to that, 2021. And then some time passed. Actually, the issue was the problem didn't go away. So that was still, yeah, the thing. Basically, when customers were asking us, which IP range do I need to, or which IP do I need to allow on my database cluster or database, we always said you need to allow all the NKE networks, because we don't know which IP your desired VM will have at some stage. Yeah. And then the second attempt, right? Problem didn't go away, so we had to, yeah, tackle it again. And that was quite some days later, October 2023. And then, yeah, requirements haven't really changed. And actually, Pavel sitting over there took that over. Yeah, me being freed. Maybe I was also Kuma biased. I don't know. So it was cool that Pavel took that over. And back then, Istio seemed to be that prominent service mesh. It won the war against Linkerd or whatsoever. So yeah, we had a look at it. And results, well, it took us a really long time to get into that topic. October 2023, I said, I had a look 2 days ago when the ticket was actually closed and finished, and that was in December. So it roughly took 2 months to get us totally into that. I won't show you the internal documentation because it's huge. Pavel did a really good job there to figure out all the details. To sum it up quickly, Istio has a really high amount of CRDs, where I think you don't really know what is doing what. The documentation, also there's a high amount of documentation which you need to understand, and how to configure things. And then we also had the SPIFFE Spire related issues. So if you have a sidecar-based approach, then all your packets are basically encapsulated with MTLS to provide an identity. And that identity is normally for the service account which your pod is executed with. So on the other side, you then know you have the identity, you know the service account, which is basically talking to you. And that SPIFFE Spire is a framework for creating trust relationships and stuff like that. And the format of that identity is was quite strict, right? If it was mesh.namespace.service account.something, I don't know, but in the end we would like to have way more stuff encapsulated in that, like NKE cluster or organization. We'd like to have more, and it was hard to actually figure out how that's done. So overall, debugging with sidecar is horrible. I mean, I don't know if you've ever done that, but I think it's not great. Overall complexity is too high with Istio. So compared to Kuma, yeah, no change of results here. So yeah, and then we left it at this stage. So basically, project again delayed a bit. In the meantime, there was also a different problem. Customers have NKE clusters and they have their legacy firewalls at some place somewhere outside, and the problem stays the same: which IP do I need to allow? But this time it's not 9 internal connection A to B, but connection from 9 to somewhere else. So static egress was the thing. July 2024, we implemented a solution to have like a static egress IP for NKE pods. You can select which pod should have basically or should talk to the outside with that IP via labels and or selectors basically. And that allows to connect the services outside with a static IP. It's also HA based, so whenever some node goes down, the traffic flows over a different node with having still the same IP. And yeah, but it needs an additional IPv4. And if you, for example, you have 3 databases per like environment, production, staging, and testing, but you just have one NKE cluster with different namespaces per environment, you would need 3 static egress resources. 3 IPv4s, stuff gets pretty expensive, right? And yeah, that is a bit of a problem there. And it also doesn't encrypt the traffic. It's just routing in the end. So we had to see that this is not really a long-term solution to connect services in 9. It was not developed for that, but it works as a workaround for a bit. And then the third attempt to solve that. September 2024, problem didn't go away, and this time on the plate, my friends. Traffic mesh, Kuma, again, Linkerd, and Istio ambient mesh. So yeah, I was put back into place for that. I don't know, I guess. Yeah, was not a very prominent topic in the platform team. Yeah, traffic mesh, I just had a look at it. I'm using traffic personally, that's why I had a look. It's not really, I didn't really test into that because the documentation already revealed that the connection to external VMs is not possible. It uses proxy pods on each node instead of sidecars. It's cool. And they like if you have a look at the documentation, the architecture is very lightweight, and that's always what I love. Like if it's easy to grasp and understandable, that's cool. Yeah, but it's more meant to be used on one cluster and not like over multiple clusters. Yeah, I just had a look. I just wanted to see how did the project evolve, what was updated, and our old desired architecture still like holds true. 1 mesh per organization, 1 zone per K8s cluster and per VM. That's already what we had back then. Interestingly, what I just showed you before, I forgot that it exists, so I thought about the whole thing again. I came up with a solution, and then someone told me, hey, we actually had a look at this already. And I compared, and I said, yeah, still holds true. Good stuff. There's still IP-based authentication between remote control planes and global control plane, aka you need to go enterprise. We would need quite some additional IPv4 addresses, and the complexity stayed the same. So overall, some things got fixed actually, like the port is always needs to be TP80, for example. That's not the case anymore. There's a workaround for that, or like a feature for that. So it evolves, but still complexity, I think, is quite high. Linkerd, yeah, Linkerd always, I think, like what they announce or what they say always, their statements is everything is basically very easy to configure, and that's also something I like. So you have no global control plane like in Kuma in Linkerd, but every cluster has its own control plane. That's also cool. Like if your global control plane dies, in that case, everything is still fine, right? To connect between clusters, a gateway component is needed. Obviously, they also use proxy. They don't use like Envoy. They have their own proxy coded, and it's also but NTLS sidecar approach. So, yeah, sidecar approach basically. What it was interesting is the concept of service mirroring. So, if you don't have a global control plane, how does the source know where to connect to? If there's no global registry of services. And they have like components which connect to the other clusters and check Kubernetes services for annotations. So if you say on your target cluster, hey, actually you can connect to that service, you annotate it with a specific string value, the component on the source will detect it. They copy over the K8s service, right? But they replace the endpoints. I don't know if you know about endpoints of Kubernetes, which is those are basically the IPs for the service, and they replace it with the gateway component of the other side. So whenever on the source you connect to that service, you will connect magically to the remote gateway. The problem with that is that it's called service mirroring, and it exactly does that. Mirroring means one-to-one, also namespace-wise. So actually, they expect that you have the same namespaces set up on all the connected clusters, and that's not the case for us. I mean, especially for customers' clusters, we don't know which namespaces they will come up with. So that doesn't really fit into our concept. I looked a bit into the Go code, and yeah, it was not really changeable because the whole system is also established in the identity trust. Like again, identity is based on a string, right? And that actually was, yeah, really baked into that. Let's call it like this. Yeah, and then another story. I did not get the multi-cluster feature to work, and the thing is, Linkerd is really, I mean, the whole setup is really easy. And I'm saying here, thanks Bitnami for the learning. The thing is, how I tested is, I just set up like an NKE cluster, my service cluster in my demo, and then another NKE cluster for the customer. And I just wanted to get a connection from client to a Redis pod running on the target. And to set up Redis, I used the Bitnami Redis Helm chart. Basically, just I can type Helm install, you know. And the thing is, everything went fine. And by default, it starts like a primary node or primary pod and 2 secondaries, and they connect to primary. And that looked really well. Everything was fine. But then to get those pods into the service mesh, you again need to annotate them. I think annotate or label, I can't remember, but you need to do something. Then those pods get restarted and the sidecars get injected. And when that happened, actually, these secondaries couldn't connect anymore to the primaries. It wasn't possible anymore. So I digged a bit, like, what's going on? And then I said, actually, that's not my task to figure it out, because if I still have the primary, that's enough for my client to connect. I don't care about the secondaries, right? So yeah, in the end, I debugged a lot there, and I didn't figure it out. I couldn't connect from the client to my primary pod there. And I said, I don't know, screw it, go to the next project. There's anyway the service mirroring thing, which doesn't fit, so it's not that bad, right? And I went to the next one, which I'll show you in a second, the Istio ambient mesh. I did the same thing, and the same thing happened again. I couldn't get it to work, and so that's not the problem of the service. That's a problem, I guess, of mine. And the cool thing about the Istio ambient mesh, though, was in the logs there was, I can't connect to, do you have a network policies established? And that rang the bell. That rang the bell, right? And I would have never thought about network policy. I guess you did, okay? I didn't. And then I checked the Helm chart, and yes, by default, they establish a network policy. And that network policy, I thought, why didn't it work? Well, if you have sidecars, your sidecars are talking to each other on different ports, and then the network policy doesn't match anymore. So same thing, yeah. I disabled the network policy and went on with Istio ambient mesh. Yeah. So yeah, Istio ambient mesh, like the, I don't know, I don't want to call it more modern service mesh, but it's supposed to be like sidecar free where possible. It's also way easier to configure. I mean, really, like configuration-wise, it's way easier than plain Istio. Yeah, the network policy led again to issues. I already told about that. But for our use case, if you want to connect from a source cluster to a target cluster, you need a waypoint proxy, because only the waypoint proxy, it's an envoy, is able to do all the MTLS thing. It's not possible otherwise, and to be honest, till I found that out, it took some time. Because there is still a lot of Istio documentation which is targeted to plain Istio, and there's also the ambient mesh documentation, and there are so many GitHub issues where I couldn't figure out, hey, is that Istio? Is that Istio ambient mesh? Is it possible at all? And in the end, I found it's actually only possible with the waypoint proxy. Yeah, the documentation was not always clear. And the waypoint proxy was not really transparent for customers. And that actually falls back to the whole network policy thing. Because if you want to establish the whole thing quite transparent on a client cluster, and they have network policies, you might just be screwed, right? Because those network policies, they suddenly don't work anymore just because your client is now part of the mesh. So we said, that doesn't really work. It's not really, yeah, you can't just like roll it out. And then we started Dream again, right? Wednesday is our office day, so we sit all together and then like, hey, actually, can we just come up with our own service mesh? Is it that hard? Yeah, you know. And that whole discussion quickly, actually, it wasn't that long, finished up with statements like, yeah, too much to implement. And we wouldn't do the same way as the others did. I mean, there were no new ideas, right? Because the other ideas are already great. It's just complex. And yeah, there's also a video. I actually checked on YouTube. Did anyone else ever implement their own service solution? And Monzo Bank from Great Britain, they actually did it back then when there was no proper service mesh. And it was really cool. The presentation was cool. But in the end, obviously, someone asked, hey, would you do it again? And he was like, no, I wouldn't do it again. Because nowadays, there's so much stuff on the market. So yeah, only negative stuff here. That's how I felt. I can actually remember I was here that was like during the last TechTalkThursday, and I did all those investigations, and I talked to one, and I was really depressed. I said, there is nothing on the market which can just like solve our, I think, in my opinion, quite simple use case. Then whispering voices. Why is it called whispering voices? Because on Wednesday we sat here, I was complaining, I'm German, right? There's no service mesh solution which just fits our need. And then from the right, and there's where Cyril sitting, he always said, tailscale, tailscale. And I was like, okay, yeah, I know it's a WireGuard-based solution. Maybe we have to manage those subnets again, right? That was always something I was a bit afraid of. And does it really, for example, provide an identity? Because normally WireGuard solutions, they don't provide an identity. You have a proxy and something talks via that proxy. But yeah, I was down, so who cares? And then we tried the tailscale and the tailscale Kubernetes operator. And tailscale, I don't know if you don't know it, but it automates just WireGuard mesh networks. It's a full mesh. There's a central control server, and it just works. And that was basically already the point where I was sold. Because like given all the things we tried out before, and then it was so easy to get something up, that was a really great thing. Because I don't know, you have to add an annotation to a Kubernetes service, and then like on the source, and then the same thing I think on the target, and then allow it in the policy and done. Like with all they also provide a magic DNS thing, so every registered device, node, machine gets its own DNS, and then you can just do it. No additional IPv4 address is needed because it uses what the host has a public IPv4, and that's what it's using already. So really cool. Annotating Kubernetes services, I already said that. The client code is open source. The control server code is not. Allows for magic DNS. And there's the Headscale project, right? There's the Headscale project, which is the control server open source implementation as an alternative control server. And yeah, the funny part about that is that I think the main developer of that works for Tailscale. Now, it got hired, yeah. That's an interesting thing which we will see in a bit. So yeah, it felt really good to be back in the game. That was really great. And yeah, we tested everything. And was it too good to be true? Well, the Tailscale Kubernetes operator actually doesn't work with Headscale. And the reason for that is the operator talks to the control server. That's cool. That's what Headscale implements. But there are, I don't know, 2 or 3 API calls actually, which go to let's call it proprietary API at tailscale.com. 2 or 3, right? So people try to solve that issue. You can sites. So let's start with the Tailscale side. So they went to Tailscale. I think they even did a PR, or I don't know, maybe only an issue. And they said, okay, here's that code. They basically implemented it, or came up with a Go interface saying if you want to talk, that's the normal Tailscale implementation. There is a Headscale implementation. And the answer was, we don't want to have any Headscale related code in Tailscale, which is fine, I'd say. It's reasonable to do so, right? You want the stuff, you keep your stuff clean. And then there's the other side. There's the Headscale side, right? And there it is more about could you just implement those REST endpoints for those 2 to 3 API calls? And that guy was, or the the answer there was that's not really head-scale's thing to do. We have gRPC, we implement the control server, that's not our part. So if you have something which can't directly talk to each other, you know, what do you come up with? A proxy, right? So basically the idea was to come up with a proxy which implements those REST API endpoints and then passes that in gRPC format to head-scale. And besides that, some things are also hard-coded in tail-scale. For example, that whole, the endpoint where the REST API is, that's hard-coded. You can't change it. So that's something, yeah, which needs to be changed. And that's actually like the solution we are now going for. Come up with such a proxy, open source it, and then try to convince tail-scale that the endpoints can be customized. That's basically the idea. I mean, the code changes on tail-scale side are not that hard, I think. It's more of a, are you doing it or not, right, thing. And yeah, and we need to integrate then the whole solution into our self-service concept so that it can be fully automated. Where are we today? The proxy is implemented, actually. It's not yet open source because we said we just want to get up like with everything and then test it, see if it works, and then we can still open source it and try to get stuff merged to tail-scale. We have an API concept of connecting services. It's a very easy API concept. You say basically from to. And then you, like from is a Kubernetes cluster and to, for example, the KVS, the key value store instance. And then all this stuff runs in the back. And you get a magic DNS and then you can just connect. There's also the policy concept, like head scale or tail scale uses tags to identify, or you can add tags to devices. And then you can say tag A is able to connect to tag B on port whatsoever. We also want to have that fully automated, so we wrote a reconciler, policy reconciler, which does that. Staging setup is also done, and we have quite some code written. What will be next? Yeah, the magic DNS setup for Kubernetes. That's actually what I'm currently working on, because what I learned like yesterday or 2 days ago, I don't know. I always thought there is like that global domain for Tailscale because Tailscale by default uses ts.net, and that's also hard-coded. You can't have anything else, right? And I always thought that there is like ts.net is hosted somewhere, but it seems like the DNS thing is always done on the client. So when you have a Linux VM, you do Tailscale up or so. It actually, we don't know how. Well, we tried to investigate, but 5 minutes weren't enough. It hooks somehow into systemd thingies and then basically provides it with you or provides you with the correct DNS. And the same for Kubernetes. We have core DNS and then you have the domain, and that domain, all the requests for that specific domain will be targeted to a name server, and that name server gets controlled by the head-scale control server. That's how it works. Allow API resources to be targeted. So in our concept, whenever there's something a target or wants to be a target, it needs some code to be implemented. Test our whole setup, well, good, and build the production environment as well, and then see if really everything works, and then open source the proxy and try to get stuff working. Yeah, release it, there you go. So that's it. That's our journey of connecting services and where we are. Any questions? Oh, thanks. No questions? Everyone is,
I have a lot, so.
Okay. So maybe the others can leave. And no.
So the second time you didn't test Cilium external workloads. I'm a Cilium
No.
So I'm curious.
I was expecting that. First thing was, if I remember correctly, for some feature you need to have Cilium Enterprise.
This is beta. It's fine. This works in open source as well.
Oh, maybe, I don't know. Yeah, no, well, to make it quick, we didn't have a look at it again, I think, right?
The CIDR clashes were the issue.
CIDR clashes as well, maybe, I don't know.
Okay.
Might be.
That was an enterprise feature back then at least. Okay. Like if we have multiple clusters, they have the same cluster CIDR.
Yeah.
And if you want to connect these, then you need enterprise.
Yeah, that would make
sense. And we got a quote and we said no.
That's also the thing, like we're not cheap asses, but the thing is, you need to basically, if you pay that, you need to make your products a bit higher, like higher priced, right? Yeah. That's the thing. Yeah. And for such a connection, for example, you provide products, a key value store, and you want to provide your customers a very easy way to connect. isn't that like, wouldn't you just expect it, that it works? Or would you actually pay like an additional fee for that? I don't know. Yeah.
I pay for enterprise, so I have a bias to that. That's why.
You're working for Roche, right? So.
Also, the use case is very different. And
Yeah.
damn it, I forgot the tails. Okay, I wait for other people for questions. I'll think again.
Are there other questions? If not, I'll get a beer. 3, 2, 1. Okay, thank you. Oh, in the last second.
I totally understand the problem and why you want to solve it, but why haven't you moved the databases to the same cluster that deploy your apps?
It's not only like on-demand databases are standalone. They are standalone. You can use your database from NKE from Deployo, like the same database, right? And yeah, and that's already it, I'd say. Right? You need it's just a database instance you want to connect to. You want to have it secured and encrypted. That's basically the use case. Like, I don't know if you ever worked, like, for example, we work with Cloud SQL from Google, and there you have a private network, I think, like by default. A private network underneath your Kubernetes cluster, your GK cluster can just connect via private IPs. No one can access your database from the public, and that's a pretty cool solution, though, right? And that's something like what we want to have as well. Yes.
You mentioned that you work with AWS and GCP and Azure, right? So do they not offer? I mean, since you have to run one of these Kubernetes clusters there, do they not offer any of this solutions for this problem?
No, we actually like that solution I was talking about is completely for 9. Okay. That's just for 9. We also offer like a managed GK product, but there Google solved it for us, right? But here, like at 9 in our data centers, it obviously wasn't solved just by someone else. Dan.
Cloudflare. Have you considered that as well as an option? Basically, you could terminate MTLS towards there and then assign that to work.
But if we talk about MTLS, we again have sidecars, right? And
depends how you do it. You could do it at the node level.
Okay. What about identity then? Yeah. Okay, that would actually be similar to what we have now. Maybe. But is that Cloudflare? Is that something?
We can talk after.
It's also like you're using an infrastructure from someone else, and we are a bit, let's say, biased with other enterprise solutions which we work with. Mm-hmm. If there's a problem, you need to talk to support, right, and get it solved. Yeah. And to be honest, in my opinion, whenever it's possible to circumvent it, do it. Really, if you have control over your own infrastructure and you know how it's working, it's the fastest way to deal with an issue, I think. So we're always a bit like, can't we just do it ourselves?
And there's the compliance question with Cloudflare, which some of our customers just don't want to have in between. So
we talk later.
Yeah.
Cool. So thanks again. See ya.